Hello guys, in this session I want to solve another problem about fluid mechanics. Then let me first introduce the reference as usual. Okay, the book we want to introduce is Fluid Mechanics, a 9th edition from Strutter and Wiley and Master Bedford. We can work on this book. This is a good book that you can have it and work on it. So let me go to the page 182. For solving this problem, one of the problem in this chapter says the velocity distribution between two parallel plates separated by a distance a is like this equation, in which u is the velocity component parallel to the plate and y is measured from normal to the lower plate. So determine the volume, rate of flow, and the average velocity, and then what is the time rate of flow of kinetic energy between the plates. And then we should make it obvious that in what direction is the kinetic energy flowing. Okay, let's get started and work on it. Okay. Okay. Let me draw a picture of that first. A plate, something like that, and a lower plate, something like that. The fluid is between these two plates. So distance between two of them is a, and the y will go from here. Then what do we have? U. As we can see it, U at the book, you can see it. Okay. First, we should, okay, we know that if we have an element here, I will draw it separately in a large scale. This is A. So if this one distance would be the x, it would be A. Okay. The differential of would be dA. Okay. So I can write dA equals dx dot dy, and we want to assume dx equals 1. Then dA equals dy. Is this right? Okay. Okay. And we know that Q, which is flow rate, mass flow rate, equals UA. Okay. So I can write in this way: differential of Q equals U and the A. Is it right? Then I put U from equation inside it. If I do that, I will have a formula, an equation such like that. Y by A minus 20 U square A square dy. Okay. I know that if I want to integrate from this equation, the limitation of y would be 0 to a. Okay. Then for knowing the Q, the mass flow rate, I have to integrate from this equation. 0 to a, or better say 1 to 2 limitation from the Q, which is equal 0 to a from this one. Okay, 10 y over a, 20 y2 a2, exactly such as this equation dy. Then if I integral from this, it would be 10 y squared to a minus 20 3a2 y cubic here, 0 to a. Okay, it equals 5a2 over a minus 20 3a square a2. It would be 5a minus 20 over 3a. Okay, then I can write it in this form: 15 minus 20 multiplied by a. This equals 5/3 a. This is our Q. Okay, so it was the first section of the A. Q mass flow rate equals minus 5/3 a. Okay, let us continue with the next one. Okay, then I want to find what is average velocity. I will show it with nu bar. Okay, I have this equation. I know that we nu bar multiplied by a will equals nu, which is different from this nu. Both are velocity, but this is average velocity and this is not average velocity. Multiplied by dA. Okay, it would be something like mass flow rate, this one. Then I can write it in this form: nu bar equals integral of nu dA divided by a. Okay, and I found it here before. It is minus 5/3 a divided by a, and I know my a is a dx, which would be a. Okay, divided by a. Then nu bar will equals minus 5/3, and the direction, if I assume this is positive direction, the direction of velocity will be to the left. Okay, this would be v equals, for nu bar, average velocity minus 5/3 meter per second. Okay, and this is meter cubic per second. Okay, let me erase all of this and write them again for the next session. Okay, I don't need these anymore. Okay, change the color to red. Okay, what I know is in constant with time rate of flow of kinetic energy between the plates. Okay, kinetic energy, time. What is the time rate of flow of kinetic energy between the plates? Okay, and the direction of that for the next one. So I know from the Bernoulli equation, or from energy equation. It has two names, Bernoulli or energy equation. G z plus nu square, which is velocity, divided by 2 plus pressure over density, equals a constant number. Okay, this is formula. This is our formula, energy equation. And which one is kinetic energy term? This is pressure. This is for kinetic energy. And this one is for head pressure. Head pressure. And this is about high. This is about pressure. This is about the kinetic energy. About the energy, okay? Energy, kinetic energy. So I will work on this now. I know that unit of velocity will be meter per second, but it has a power here as 2 by s2. Okay, I can write it in this way: meter s2. If I add a kilogram here and a kilogram here, okay, got here, then okay, what is it? Kilogram meter per second square. It is the unit for Newton. We knew that. Let me write it in this way. Newton equals G multiplied by M. M is mass, and this is a gravity. Okay. Okay. M S square for this one, and kilogram for this one. M kilogram per square will be like that. Okay, I can write it in this way. Newton meter per kilogram. Okay, this is the unit for energy. This is for energy, and this is for mass. Okay, then I can use it. This is for this term, the energy term. I can write it in this way. I can use it from this. I can use from this one to solve my problems. Actually, I know I wanna write E dot energy per divided by second, okay? M dot and this term energy U2 over 2, okay? The unit of this one should be of course no matter, because this is energy per sec. M dot kilogram per sec, and this one would be something like Newton meter per kilogram. Okay, then it would be something like that one. Eliminate these two, Newton meter per sec. Okay, then I can use this equation to write this one. Okay, let me write here, erase these ones and keep going. Okay, are you agree if I write differential of this energy? Because I don't know the value, value of that, so I would write it in this form, equals differential of m dot multiplied by nu square over second. Okay, and in another hand I have to open m dot. Which is m dot equals, I know that, let me say it in this way, rho is m over v, which v is volume, okay, different from nu. Then m equals rho v. I can write it in this way, dm equals rho dv, okay, or I can write it dm dot equals rho dv dots. Okay, so I want to use this one and put it in this one, but let me make it some more complete. Okay, for dv dots, let me change the color for you to understand better. dv. Okay, for v I can write what is the relationship between v, nu and a. I can write v equals nu to a, or not. Is it true or not? Let me try it. Let me test it if it is right. Okay. Okay, if I add that here, it would be m cubic over second. Okay, equal meter per sec and meter squared. Is it true? Yeah, totally true. It is correct. It is correct. Then instead of V, I would write that. Then I will write. Okay, let me write in this way. Differential of V dot equals nu, which is constant, dA. Okay? I will put it inside it. Then let me do it. Let me do it. Equals, this will be equals rho nu dA. Okay? And nu square second. It is right? Okay. Let me erase these ones because don't need them anymore. Okay, let me continue. I can write it in this way. Rho nu cubic second dA, which is this energy. This is this energy, okay? But I'm not finished yet. I should find E dot, okay? I should find, but I'm thinking about a place to write them. Let me erase these ones so have place to write. Okay. If I want to find E dots, I should integral from this equation. Okay. Okay. From nu third to dA. As I said before, dA equals dy. I can write it exactly in place of dA, and the value is from 0 to A. Okay? Then rho is constant, 2 is constant, integral of nu fluid dy. Okay, let me write this once. Okay, I will put, because this is velocity and we have equation for that. We have this equation for it. I will put this equation. Sorry. This equation to in place of nu 3, okay? Then equals rho over 0 to A 10 y over A minus 20 y square A square power 3 dy. Okay, you know this relationship. If we have A minus B 3, should write such a thing where A cubic dA B plus 3A B2 minus B3. Okay, I would write such a this way. Then it would be like that. U 2 equal of then y cubic a3 minus 6 multiplied by 10 3y power 4 a4 minus I will here right here is there 12 10 power 3 y 5 this is 5 a5 minus 8 multiplied by 10 3 y6 and a6 dy. Okay, then it should be like that. 2 10 3 4. If I integral it will be like that. y4 a3 minus 3 third y y5 a4 minus 3 6 here a5 10 power of 3 divided by 7 because we integral from that will be a 7 here. Okay, y7 to a6 doesn't change. Okay, from 0 to a. Okay, then the answer would be row a 2 10 3 4 minus 6 10 with power 3. Okay, the 5 here. So you calculate it by yourself to be sure of these values. Okay, I will write such a this way for this, and the answer, final answer will be like minus 45.65 row A. It does. Okay, and the unit is Newton meter per sec. Okay, and as you can see this is negative, so the direction like velocity is to the left, okay, and this was the for the last section of question, in what direction the kinetic energy flow. This is the value of kinetic energy rho A multiplied by this number, and the direction is to the left because this is negative. Okay, it was the solution of this problem. I hope you enjoyed that one, and take care, have a good time, bye bye.